Hi students, the question is prove the statement 1 square plus 2 square plus 3 square plus etc. up to plus n square is equal to 1 by 6 into n plus 1 into 2n plus 1 by using the principle of mathematical induction. So by using the principle of mathematical induction, you have to prove this statement. So first of all, you have to consider the given statement as P of n. So let P of n be the given statement. So first you have to prove the basic step. So basic step is for n is equal to 1, we have to prove the given statement is true. So left hand side LHS, in the place of n you have to replace 1. So basic step is for n is equal to 1. So LHS is n square, therefore 1 square, the value is 1. Similarly, right hand side, so RHS, in the place of n you have to replace 1. Therefore RHS is 1 by 6 into n plus 1 into 2n plus 1, which is equal to 1 by 6 into, in the place of n you have to replace 1. Therefore 1 into n plus 1, 1 plus 1 into 2n plus 1, therefore 2 into 1 plus 1, so which is equal to 1 by 6 into 1 plus 1, the value is 2, therefore 2 into here, 2 into 1, 2 plus 1, it is 3, which is equal to, so 2 3s are 6, so it will get cancelled, so 2 3 and this 6 will get cancelled, which is equal to 1. Therefore LHS is equal to RHS, left hand side is equal to RHS. Therefore the statement is true for n is equal to 1. Therefore P of 1 is true. So next is the inductive step. So in inductive step you have to assume the statement is true for n is equal to k, and you have to prove for k plus 1. So next is the inductive step. So in inductive step you have to assume the given statement is true for n is equal to k. Therefore assume P of k is true. Therefore the statement is, that is P of k is 1 square plus 2 square plus 3 square plus etc. up to plus k square is equal to 1 by 6 into k plus 1 into 2k plus 1. Just we replaced n as k. So in the place of n, the given statement is in terms of n. So here we have assumed that the given statement is true for n is equal to k. Therefore in the place of n we have replaced just k. So next you have to prove for k plus 1. Therefore I have to prove the statement is true for P of k plus 1 is true. So therefore what we have to prove, that is we have to prove 1 square plus 2 square plus 3 square etc. up to plus k plus 1th term. So here k plus 1 the whole square is equal to 1 by 6 into, in the place of k you have to replace k plus 1. Therefore k plus 1 into, the next term here it is k plus 1. Therefore for k plus 1, therefore the k plus 2 into, in the place of k it is k plus 1 plus 1. So it is equal to 1 by 6 into k plus 1 into k plus 2 into, multiply this 2 inside, therefore 2k plus 2 plus 1, therefore 3, therefore 2k plus 3. So this is the thing we have to prove. So we have to consider the left hand side and we have to prove the right hand side. Therefore LHS is, so left hand side is 1 square plus 2 square plus 3 square plus etc. up to plus, here it is k plus 1 the whole square, that is the k plus 1th term. So before writing the k plus 1th term, just you have to write the kth term, that is k square plus k plus 1 the whole square. Why we are writing the k square means we know the value, that is P of k is true, like that we are assumed. Therefore up to kth term we can replace that value. That's why we are writing kth term first, then k plus 1th term. So 1 square plus 2 square plus 3 square plus etc. up to this k square, the value is 1 plus 6 into k plus 1 into 2k plus 1. So just we are replacing that value 1 by 6 into k plus 1 into 2k plus 1. So the remaining term is k plus 1 the whole square, k plus 1 the whole square. So first we are taking the LCM. So here the LCM is 6. So here it is 6. Therefore the term becomes k into k plus 1 into 2k plus 1 plus for the second term 6 into k plus 1 the whole square. So now we can write as 1 by 6 as common. So we can take it outside. 1 by 6 into the term becomes k into k plus 1 into 2k plus 1 plus 6 into k plus 1 the whole square. Next we have to simplify it, which is equal to 1 by 6 into, just multiply this k inside. Therefore k into k square plus k into 1 k. The next term is 2k plus 1 plus here it is 6 into, here it is of the form a plus b the whole square. So therefore the formula for a plus b the whole square is equal to a square plus 2 into ab plus b square. So here in the place of a it is k and in the place of b it is 1. So just to replace that value. Therefore a square it is k square plus 2 into ab, 2 into k, for b it is 1. Therefore plus b square, 1 square, the value is 1. So which is equal to 1 by 6 into, next you have to multiply this first term with the second term. So multiply this k square plus k with the second term. Therefore k square into 2k. Therefore 2 into k square into k, the value is k cube. Plus again you have to multiply k square with 1. Therefore k square into 1, it is k square. Now multiply k with 2k. Therefore plus 2 into k square plus k into 1, the value is k. The next term is plus, next you have to multiply this 6 inside. Therefore 6 into k square plus 6 2s are 12k plus 1 into 6, 6. Next is we have to combine the terms, which is equal to 1 by 6 into, here it is k cube, only one term consists of k cube. Therefore we can write as it is 2k cube plus, next we have to combine the k square terms. It is k square, 2k square plus 6k square. Therefore when we add 6 plus 2, 8, 8 plus 1, 9. Therefore 9k square plus, next is the kth term. So kth term, the value is k and here it is 12k. Therefore 12 plus 1, it is 13k. 13k plus the constant term. So constant term is here only 6. So now it is a cubic expansion actually. So we have to find the roots of this cubic expression. So since it is cubic expression, so first we have to find a root by using synthetic division. So to find the roots by using synthetic division, just we have to write the coefficients. So coefficients of k cube is 2. For k square the coefficient is 9. For k the coefficient is 13 and the constant term is 6. So just by using trial and error only we have to find the roots. So here I am using the value as minus 1. So since all term is positive, therefore definitely one term, the roots will become negative. So just I have substituted minus 1. So synthetic division means first step is you have to put 0. So here you have to add this way and you have to multiply crossly. Therefore 2 plus 0, the value is 2. 2 into minus 1, the value is minus 2. Next you have to add 9 minus 2, therefore it is 7. 7 into minus 1, so 7 into minus 1, it is minus 7. 13 minus 7, 13 minus 7, the value is 6. So 6 into minus 1, the value is minus 6. Therefore 6 minus 6, the value is 0. So if we get 0 at the last, we can say that this is a root. So here it is, the expression is in terms of k. Therefore k is equal to minus 1 is a root of this equation. So k equal to minus 1 is a root, means k plus 1 is a factor. It is a factor. Therefore this cubic equation reduces to 1 by 6 into, for 2k cube plus 9k square plus 13k plus 6, we have calculated a one factor as k plus 1. Therefore k plus 1 into, the remaining factor is, here we get as the coefficient is 2, 7, 6. Therefore the cubic function now reduces to a quadratic function with the coefficients as 2 into k square. Plus next coefficient is 7, therefore 7 into k, plus the next coefficient is 6, that is the constant term 6. Now we have to find a root for this quadratic equation. So here in this quadratic equation, the sum of the root is equal to 7 and the product of the root is equal to 6 into 2, 12. So we have to find two roots in which sum is 7 and the product is 12. Therefore the roots are, we can have the value as 4 and 3. So when we add these two numbers, 4 plus 3, we get 7. When we multiply this number, 4 3s are, we get as 12. Therefore we got these two values. Therefore now this equation, which is equal to 1 by 6 into k plus 1 into this 2k square plus 7k plus 6 becomes 2k square plus this 7k is splitted as 4 and 3. Therefore 4k plus 3k plus the next term 6. So which is equal to 1 by 6 into k plus 1 into, next consider the next two term. In this two term, what is common? 2k is common. If we take 2k as outside, the remaining term is k plus 2 plus, consider the next two term. In the next two term, it is 3 is common. Therefore 3 into, therefore k plus 2. So which is equal to 1 by 6 into k plus 1 into, now consider these two terms. In these two terms, k plus 2 is common. Therefore the remaining term is 2k plus 3. Therefore which is equal to 1 by 6 into k plus 1 into k plus 2 into 2k plus 3. So this is the right hand side of p of k plus 1. So that's the thing we have to prove. That is, we have to prove as 1 by 6 into k plus 1 into k plus 2 into 2k plus 3. So that's the thing we have got it. Therefore the statement is true for p of k plus 1. P of k plus 1 is true. Therefore in general we can say that the statement is true for n. Therefore the given statement holds. Therefore 1 square plus 2 square plus 3 square plus etc. up to plus n square is equal to 1 by 6 into n plus 1 into 2n plus 1. For every n belongs to n, the given statement is hold. So this is the way we have to prove by using the principle of mathematical induction. Hope you understand. Thank you.